Welcome back, space explorers. Today we're turning our attention to one of the most unique and underrated planets in the solar system, Uranus. This ice giant may not get as much attention as its neighbors, but it's full of surprises. From its mysterious tilted rotation to its icy atmosphere, Uranus is unlike any other planet we've explored. Curious about what makes this distant world so special? Stay tuned as we uncover the incredible facts and hidden wonders of Uranus. Let's dive in. Introduction. Uranus is the seventh planet from the Sun. It is a gaseous cyan-colored ice giant. Most of the planet is made of water, ammonia, and methane in a supercritical phase of matter, which astronomy calls ice or volatiles. The planet was named for Uranus, the Greek god of the sky, as suggested by Johann Bode. It was discovered in 1781 by astronomer William Herschel, although he originally thought it was either a comet or a star. It was 2 years later that the object was universally accepted as a new planet, in part because of observations by astronomer Johann Bode. Uranus was the first planet found with the aid of a telescope. Uranus is a very cold and windy world. The ice giant is surrounded by 13 faint rings and 28 small moons. Uranus rotates at a nearly 90-degree angle from the plane of its orbit. This unique tilt makes Uranus appear to spin sideways, orbiting the Sun like a rolling ball. This means that in an 84 Earth-year orbital period around the Sun, its poles get around 42 years of continuous sunlight, followed by 42 years of continuous darkness. Size and distance. Uranus is 4 times wider than Earth. If Earth was the size of a nickel, Uranus would be about as big as a softball. With an equatorial diameter of 51,118 kilometers, it takes sunlight 2 hours and 40 minutes to travel from the Sun to Uranus. 1 astronomical unit is the distance from the Sun to Earth. Uranus is about 19 astronomical units away from the Sun. Orbit and rotation. Uranus is also one of just 2 planets that rotate in the opposite direction than most of the planets. 1 day on Uranus takes about 17 hours. This is the amount of time it takes Uranus to rotate, or spin once around its axis. Uranus makes a complete orbit around the Sun in about 84 Earth years, 30,687 Earth days. Uranus is the only planet whose equator is nearly at a right angle to its orbit, with a tilt of 97.77 degrees. This unique tilt causes Uranus to have the most extreme seasons in the solar system. For nearly a quarter of each Uranian year, the Sun shines directly over each pole, plunging the other half of the planet into a 21-year-long dark winter. Surface. Uranus, like other gas giants, doesn't have a solid surface. The standard model of Uranus's structure is that it consists of 3 layers: a rocky, silicate/iron nickel core in the center, an icy mantle in the middle, and an outer gaseous hydrogen/helium envelope. The core is relatively small, with a mass of only 0.55 Earth masses and a radius less than 20% of the planet. The mantle comprises its bulk, with around 13.4 Earth masses, and the upper atmosphere is relatively insubstantial, weighing about 0.5 Earth masses and extending for the last 20% of Uranus's radius. Composition. Uranus is made up of a rocky core, a liquid layer of water and ammonia, and a gaseous atmosphere of hydrogen, helium, and methane. Appearance. Uranus appears pale blue because the methane in its atmosphere absorbs red wavelengths of sunlight. Gravity. Uranus's gravity is about 90% of Earth's gravity. Temperature. Uranus is the coldest planet in the solar system, with temperatures ranging from -370 degrees Fahrenheit to 116 degrees Fahrenheit. Axis. Uranus's axis is almost parallel to its orbital plane, so it spins almost on its side. Atmosphere. Uranus' atmosphere has a troposphere, stratosphere, thermosphere, and ionosphere. The atmosphere is primarily made of hydrogen and helium, with a small amount of methane, water, and ammonia. Color. Methane gives Uranus its signature blue color. Clouds. Uranus' atmosphere has dynamic clouds that change rapidly as it approaches equinox. Temperature. Uranus' atmosphere has a minimum temperature of -224.2 degrees Celsius, 49 K, making it colder than Neptune in some places. Wind. Uranus has some of the fastest winds in our solar system, reaching speeds of up to 560 miles per hour, 900 kilometers per hour. A wind direction. Winds at the equator blow in the opposite direction of the planet's rotation, while winds closer to the poles flow with the planet's rotation. Magnetosphere. Earth's magnetic field creates a bubble around Earth that helps protect our planet from some of the more harmful effects of energetic particles streaming out from the Sun in the solar wind. Uranus's magnetosphere contains charged particles, mainly protons and electrons, with a small amount of H2+ ions. Like Earth, Uranus has an unusual magnetosphere with a number of unique characteristics, including a magnetic axis, tilted nearly 60 degrees from the planet's axis of rotation, a magnetic dipole, offset from the center of the planet by 1/3 of the planet's radius, a magnetosphere tail, extends millions of miles into space opposite the Sun, a magnetic field lines, twisted into a long corkscrew shape by Uranus' sideways rotation, auroras, not in line with the poles like they are on Earth, Jupiter, and Saturn, a structure and dynamics, dependent on diurnal rotation and seasonal azimuth. The magnetosphere of Uranus is formed by the interaction between the planet's magnetic field and the solar wind. Its unusual shape and characteristics may be due to the following. The planet's rotation axis is tilted over 90 degrees, relative to the solar system's revolution axis. The magnetic axis has a large tilt relative to the rotation axis. The magnetic field may be generated by a different mechanism than that of Earth, Jupiter, and Saturn. Rings. The ring system was definitively discovered on March 10, 1977 by James L. Elliott, Edward W. Dunham, and Jessica Mink using the Kuiper Airborne Observatory. The Uranian rings are composed of extremely dark particles, which vary in size from micrometers to a fraction of a meter. Uranus has multiple rings, including a set of 9 narrow, dark rings and 2 outer rings. Inner rings. These 9 rings are narrow and mostly dark gray. The widest ring is called Epsilon, which is about 50 kilometers wide. Outer rings. There are 2 outer rings, one reddish and one blue. The reddish ring is similar to dusty rings found elsewhere in the solar system, while the blue ring is similar to Saturn's E-ring. A ring material. The rings are made of dark material that reflects only about 2% of sunlight. They could be made of dark organic material or frozen methane. In order of increasing distance from the planet, the rings are called Zeta 6, 5, 4, Alpha, Beta, Eta, Gamma, Delta, Lambda, Epsilon, Nu, and Mu. Some of the other larger rings are surrounded by belts of fine dust. Natural satellite of Uranus. Uranus moons are unique in being named for characters from the works of William Shakespeare and Alexander Pope. All of Uranus' inner moons appear to be roughly half water ice and half rock. The composition of the outer moons remains unknown. Uranus has 28 known moons, including 5 major moons and several smaller moons. Major moons: Miranda, Ariel, Umbriel, Titania, and Oberon are the 5 largest moons of Uranus. They range in radius from about 150 to 500 miles. Miranda has a unique surface with huge canyons, terrace layers, and a mix of young and old surfaces. Ariel, the brightest moon of Uranus with canyons, valleys, and mini craters. Umbriel, very dark. Titania, the largest moon of Uranus, covered with small craters, a few large craters, and very rough rocks. Oberon has an old, heavily cratered surface. Smaller moons. These moons are tiny, as little as 8 to 10 miles across, and blacker than asphalt. They orbit so closely that scientists are surprised they haven't crashed into each other. Juliet, Puck, Cordelia, Ophelia, Bianca, Desdemona, Portia, Rosalind, Cressida, and Belinda. These moons were discovered by the Voyager 2 spacecraft in 1986. Perdita, an 11th tiny inner moon that was discovered by Voyager near the orbit of Belinda, but remained unnoticed in the images until 1999. Potential for life. The environment of Uranus is not likely to support life as we know it. Some reasons include extreme temperatures and pressures. Uranus's temperatures and pressures are likely too extreme for organisms to adapt to. The pressures inside Uranus are enormous at the temperatures where life could exist and would crush life. A no solid surface. Uranus is mostly made up of ices, including methane, water, and ammonia. A no energy source. Life on Earth requires sunlight to provide energy, but there's no process inside Uranus that would give life a form of energy. Impact of Uranus on the life of Earth. The existence of Uranus and other ice giants in our solar system may have been critical for the existence of life on Earth. Here are some ways Uranus could impact Earth. A gravitational pull. If Uranus were to collide with Earth, its gravitational pull could cause volcanoes to erupt and earthquakes to destroy the planet from the inside. Ice giants in Earth's existence. The existence of ice giants in the outer solar system may have helped prevent Earth from being completely destroyed.
How many artificial missions have sent to Uranus? Only one artificial mission has visited Uranus, NASA's Voyager 2, which made a close flyby of the planet in January 1986. The spacecraft traveled over 1.8 billion.
Summary. In shorts, we learned that Uranus have unique tilting towards axis which make unique magnetosphere which leads to unique season. Outro. Thanks for exploring the mysterious world of Uranus with us. We hope you've enjoyed learning about its strange tilt, icy atmosphere, and all the fascinating details that make it such a unique planet. If you like this video, be sure to give it a thumbs up and share it with your fellow space enthusiasts. Don't forget to subscribe and hit the notification bell so you won't miss out on our next cosmic adventure. Got any questions or thoughts about Uranus? Let us know in the comments. We'd love to chat with you.